So my name is Alon. I'm currently a security researcher at SafeBreach, which is a breach and attack simulation. Simply put, we execute attack simulations safely on customer environments to validate their security posture. At SafeBreach, I'm responsible for doing original research projects, finding vulnerabilities, finding critical vulnerabilities, reporting, and then presenting in big conferences such as Black Hat and DEF CON. The main motivation for my research, it came to me when I first read the article about the Black Lotus UEFI bootkit, which is a UEFI bootkit that was able to bypass secure boot, which is a very important security feature that a lot of other security features rely on. And it was able to bypass this feature on a fully updated Windows 11. But it was not a new zero-day attack. It was not a new vulnerability. Instead, what Black Lotus did was to exploit an old vulnerability. And the way it exploited an old vulnerability, which was already fixed, is by employing a downgrade attack against the Windows Boot Manager. And this whole thing where this bootkit, a very dangerous one, was able to work on a fully updated machine by employing a downgrade was really interesting for me. And I really liked this capability. So I first looked at the secure boot implementation and how Microsoft protected against secure boot downgrades, which is a very big challenge. But I saw that Microsoft basically added a revocation mechanism to secure boot. We'll not dive deep into the details of how they did it and what were their mitigations. But when looking at secure boot downgrade mitigations, my first question was if there are other critical components that may have been overlooked and may still be vulnerable to downgrade attacks. So that was my main motivation as for why I decided to research downgrade attacks on Windows specifically.
So you saw they made changes specific to secure boot that sort of said, okay, but downgrade attacks could work against other components.
Yeah, so downgrade is a known attack. It's not a new attack. I didn't invent downgrade attacks. It was used in cryptographic attacks as well. So yes, that was the first thing that came into my mind. Are there any other critical components that may have been overlooked?
And the idea behind downgrade attacks is by downgrading the software, you're putting it back into a state where there might be exploitable vulnerabilities that can then be used against it. Security updates are now gone.
Yeah.
That's a general idea behind downgrade.
Yeah, you revert software, you downgrade software to an old and vulnerable version of it. And then now that the vulnerable version is used, you can exploit an old vulnerability source in this vulnerable software to then elevate privileges. Or in other cases, it depends on the scenario, but generally the form of downgrade is reverting and then exploiting. So it usually consists two steps. You first downgrade and then you exploit.
So you said, let's look for other opportunities for downgrade attacks. Where did you decide to focus your attention and what were some of the things that you found in your research?
When I decided that I want to research downgrade attacks on Windows, I've had to form a reliable way to downgrade some of the components of Windows. So that was my first step. And when I looked at it, I defined multiple principles that will help me in finding a suitable component. So I didn't want EDRs to detect my downgrade. I didn't want future updates to overwrite my downgrade. I didn't want tools to be able to revert my downgrade. And I also didn't want the operating system to look as if it is not updated. I wanted it to look as it's fully up to date. Right. When I found that the Windows update process will be the best option for me to target because it is the least expected one to perform downgrades. And also, I believe there could be some interesting findings in there. I found some online resources, but not many diving into the actual internals of how it works, what are the verification checks, etc. So I decided to focus on Windows updates. I first looked at its architecture, and I found a very interesting flaw or misconfiguration that led me to basically control all of the actions that are performed during an update. So when you're performing updates, there is a list that is saved into a location in your computer. It's an XML file that states what actions to perform as part of the downgrade. And usually this list should not be controlled by entities other than Trusted Installer, which is the service, the entity that performs the updates. But I found a way to control this file without being Trusted Installer. And then I was able to basically do whatever I wanted with the update. So not only downgrading, basically, I could also create files, delete files, do everything that I wanted. If there were no signature detections, I could also load my custom kernel. So I've had this capability, but that would of course not work because there are mitigations, and that's why downgrades are more valuable in that sense. So yeah, I found this flaw, and then once I've had this capability, I looked for what components may be vulnerable. So I was able to downgrade the kernel, the Windows kernel, DLLs, drivers, I didn't find any mitigation that was there to prevent me from downgrading this kind of stuff. And I could also go back to major versions before, so I was not limited to only Windows 11.
Was that just by modifying this kind of instructions file?
Yeah, that was by modifying this action list.
Yeah.
And yeah, I was able to downgrade everything. I didn't find any mitigation.
Literally just swapping one file name and
Usually it depends on what component you're targeting. So it could be a component with lots of dependencies, and then it is more challenging. You need to also make sure that you modify dependencies, and then you need to make sure that it doesn't hurt other dependencies of the dependencies. But generally speaking, if you target a component without lots of dependencies, that would be much easier to exploit. For example, I targeted the hypervisor, and it doesn't have many dependencies. It doesn't have dependencies at all, only its loader, which loads it. So it was good because the hypervisor is the most privileged entity of the virtualization stack, which I'll talk about in a second. But why it was good, because that was the most privileged entity and also the easiest to downgrade. And by the way, for example, the boot manager that Black Lotus downgraded also, I don't think it has many dependencies, if any. So it's also a valuable target for downgrade. Now, when I've had this downgrade ability, I looked for components, as I said, and I came across the virtualization stack at Windows, which is really an important area that Microsoft relies on to implement new security features. The reason that it is more secure, because it shouldn't be compromised even from the normal kernel, even from the kernel of Windows. So it's like a new virtual machine to store secret keys to implement new security features. And one of my key findings is that I was able to, first of all, disable VBS, which in certain scenarios where it is configured with a UEFI look shouldn't be possible, only with physical access, and I was able to bypass it. And I was also able to escalate privileges to VBS, to the virtualization stack. And I found that there's no downgrade mitigation in any area of the virtualization stack. So if we talk about secure processes, the secure kernel itself, the hypervisor, so that's very interesting.
Do you think is this a feature, not a bug? Is this just evidence that, yeah, because Microsoft wants the ability to downgrade in the event that some flawed or CrowdStrike type situation, some flawed update goes out and they want everybody back? And yeah, we're not going to put restrictions.
So that's a good point. Microsoft really wants to have the ability to revert updates if they want to, because maybe updates are buggy, as you said.
Yeah.
But when it comes to these areas, I don't think it should be, maybe it should be restricted very well. Maybe it should be initiated from a trusted area and not from administrator, for example, because if an administrator can revert a patch in a privileged component, then it's not a good idea. If we talk about the design of it, because then he would be able to, by design, escalate privileges, right? If we talk about secure boot and the way that Microsoft handled these downgrades, so they basically made it impossible. In secure boot, they basically added a revocation mechanism, and this revocation mechanism is not downgradable. It's a UEFI variable called DBX. It's append only, it's authenticated. I think it could be reverted if you have physical access, but generally speaking, you cannot revert the DBX. You cannot revert the revocation list. And that is because secure boot is an important component that you don't want to expose admins to affect secure boot. And that's what I think should happen in the virtualization stack as well, because it is also a security boundary that is crossed from administrators similar to secure boot.
And the sad reality is in that a lot of organizations, end users are administrators for their own systems, right?
Yeah, so that's the default behavior in Windows, to be an administrator. And even if a user is a standard user, it's really hard to work. Most of the software that you install today requires administrator. If you're not an administrator, you cannot elevate. You need an approval from other administrator, which makes it really hard to work. I know that Microsoft works on some improvements in that area. So I think they will do adminless Windows in the Windows 11 2024. So that may help organizations and also end users not to be administrators. But nowadays, it is a big problem. And it was also the reason why VBS was one of the reasons, from my perspective at least, why VBS was introduced. Because VBS attempts to protect from a compromised kernel. If admin to kernel is not a security boundary, if admin to normal kernel is not a security boundary, and lots of users are running as administrators, then it means that lots of users could easily compromise the kernel because admin to kernel are not fixed. And then this created a situation where you have a standard user, but not many use this standard user. And then most, or not most, but a lot of users in Windows could compromise the kernel. So Microsoft moved a lot of functionality, critical functionality, from the normal kernel to this secure world, to this virtual environment. If we take Alsace, for example, which attackers would always dump and extract credentials from it. So the way that now it works with the virtualization stack is that Alsace was moved. The normal Alsace is still in the operating system, in normal one. The process exists, but it only contains the encrypted blobs. And the real secrets are moved to this secure world, to the virtual environment, which cannot be compromised from the kernel. So yeah, the virtualization stack is really an important feature, which I think it is a security boundary and shouldn't be downgradable from administrators, or at least in a controlled way.
One of the things that really surprised me in your talk was your ability to down elements, critical elements of OS, but have Windows say, yep, it's updated, basically not detect that those elements had changed.
There's no versioning checks. So that means when Windows says that it is fully up to date, I think that what happens under the hood is that it will check for updates. And if it doesn't have any updates to install, then it will say that it is fully updated. And then the reason that it still says that we're fully up to date even after the downgrade is because the downgrade is basically an update. So as part of the downgrade, we didn't uninstall any update. And so that's why Windows will think that it is fully up to date, while in practice it has some components that are downgraded, because it will go and check for available updates. We'll see that there are no available updates and we're fully up to date.
But if you were to ask most IT administrators what is fully updated, they would probably think it means it's running the latest and greatest of everything, right?
Yeah. This check is not your fully up to date one, since it doesn't check versions, as we saw. If we downgrade something, it doesn't detect it. So the definition, there is a gap between what the IT administrators would say. If they would say that if you're fully updated only if you run the latest software, but in Windows, you're fully up to date if you have no missing updates. But if you got downgraded, then you're not running the latest software, and then you're not fully updated.
Talk about how this might be used by a malicious actor.
Generally, my talk focuses on after that an attacker already gained initial access to the machine, and then I show two vectors, one from a privileged user and one from an unprivileged user. And then the way that would work is the attacker would need to bring with him or use the component store in Windows to get the vulnerable software.
So this would not be the initial stage of the attack. That would have been some counting over or something like that.
Yeah, it could be social engineering or a vulnerability that was exploited, misconfiguration. So in order to exploit, an attacker would need to bring this vulnerable software with him or utilize the component store to retrieve it from the operating system. And then he would execute the downgrade. And for example, if we target, let's say, credential guard, the process that holds the secrets of the machine, he will downgrade. And then after the downgrade, he will exploit a vulnerability sourced in this vulnerable software that now runs in credential guard. And then it will be able to elevate to this isolated user mode process, extract credentials, extract secrets, and leave there. In other cases, let's say if he targets the hypervisor, which is the most privileged area, he could potentially build an hypervisor rootkit, which is very interesting capability. We don't see many of these. The hypervisor is more privileged than the kernel. And what's interesting here is that theoretically an attacker could create his own virtual environment that will be able to access all of the other virtual environments, but none of the others will be able to access the attackers. This is how I think an hypervisor rootkit with VBS, with a virtualization stack, can look like, and it can be very devastating, because you wouldn't know even that an attacker is currently on the machine, but he basically has visibility on everything, and you didn't have any visibility to what the attacker does. That's a very interesting area to look at.
So you reported these findings to Microsoft, and what was their response?
So we responsibly disclosed everything to Microsoft back in February, and they confirmed most of the vulnerabilities, and they asked us to direct any questions regarding their remediation to them directly. And also they have multiple online advisories which you can look at. But generally, Microsoft was very cooperative, and we thank them for the great cooperation in these cases.
Should your IT administrators, your security team be doing to monitor for what might be suspicious behavior related to downgrades of Windows? Is there a heuristic, certain types of things they should be monitoring for and flagging?
So I think one of the things that they could do is to monitor, first of all, elevations from administrator or user to trusted installer, which is the user that implements all of the updates. That's the first thing that they should do. And I think that some VDRs currently do it. Another thing would be to monitor this pending.xml, this action list, to monitor who touches it and monitor the registry key. I think the work would be to actually make trusted installer enforced. So that would be restricting the registry keys to be only accessible to trusted installer, making elevations impossible. And that would also make the whole takeover impossible as well. Another thing that it could do, which probably be more challenging, is versioning checks. So they could implement versioning checks to see if something gets downgraded. So these are the things that I would recommend doing.
But my sense, I don't know about you, is that most companies probably are not monitoring those files right now.
So right now, I don't think they monitor these files because this research is new.
Yeah.
But I believe they should, in order to downgrade, in order to mitigate this attack, they should monitor these files and make sure that they are well aware of the danger that downgrade pose to their environments, to their organization.
If you like what you heard, check out ReversingLabs.com for more interviews, webinars, and podcasts with leading cybersecurity experts.